Solving system of linear equations by substitution method. Welcome to Mark's Math Methods. There are 5 steps to solve a system of 2 linear equations by substitution. Do you know them? Well, here's a system. Y equals 2x minus 1 and y equals negative x plus 2. Step 1. Solve one of the equations for one of the variables. It doesn't matter which variable. It doesn't matter which equation. I'm going to look for one that's already done. Oh, I do see one that's already done. The first one says y equals. So it's already been solved for one of the variables. I call the y the short name and the expression 2x minus y the long name for y. So the short name for y and the long name for y. It's like a nickel is 5 pennies. So the short name would be the nickel, the long name would be 5 pennies. Step 2, substitute the long name for the short name in the other equation. So I'm going to take the 2x minus 1, put it in place of the y in the other equation, which now leaves me with 2x minus 1 equals negative x plus 2. And once we get to this point, it's pretty straightforward on how to solve it. And that's step 3. Solve for the remaining variable. So I will need to solve for x. Using my proper techniques, proper strategies, I get x equals 1. Step 4. Back substitute into an original equation to find the second variable. So I'm going to take the x equal to 1, and I'm going to put it into either the top or the bottom. It doesn't matter which one you use. I'm going to use the top one in this case. I'm going to substitute the x and put a 1 in its place. And then find the second variable, or in this case, y. So now I have y equals 2 times 1 minus 1. And I end up with y equals 1. So we think our answer is 1 comma 1. 1 for the x and 1 for the y. Notice I said think it's our answer. Step 5, check both in the other original equation. So since I used the top equation to find my second variable, I must check them in the bottom equation, which is y equals negative x plus 2. So I'm going to put in an x of 1 and a y of 1 and see if I get a true statement. I do, yay. So we only had to check the bottom equation because we know it's going to work in the top one because that's how we found our second variable. And these are the 5 steps for solving a system by substitution. Let's try another one. 4x minus 3y equals negative 24, and x plus y equals 1. Do you remember the step 1? Solve one of the equations for one of the variables. Either equation, either variable. I'm going to look for an easy one. There isn't one already done. It doesn't say y equals or x equals. I mean, I could solve for x in the top equation, but then I'm going to have to divide by 4 and I'm going to end up with a fraction for the coefficient of the y. Or I could solve for the y in the top equation, which means I'm going to end up moving the 4x and then dividing by negative 3, which is going to give me a fraction as well. Too hard. Look at the bottom equation. I've got x plus y equals 1. So I'm just going to solve for x. Just move the y over. So I solved one of the equations for one of the variables. You pick on what you want to do. You can do a lot of work. You can do a little work. Whichever one is the easiest, whichever variable in whichever equation is the easiest to do. Step 2, substitute the long name 1 minus y, for the short name x in the other equation, which gives me 4 times 1 minus y minus 3y equals negative 24. Hence the substitution method. I'm substituting it in. Step 3, solve for the remaining variable. So I removed the parentheses, collected like terms, and started solving for y, and I got y equals 4. Step 4, back substitute into an original equation to find the second variable. So I chose to use the bottom equation, x plus y equals 1, only because it's a little straightforward, faster to get to. Doesn't matter which one you pick. On the first example, I chose the top one. In this one, I'm choosing the bottom one. Always an original equation. I wouldn't want to go to x equals 1 minus y in case I made a mistake. Okay, you always want to go back to the original equation. So I plug in a 4 for the y, and I get x is negative 3. So I think the answer is negative 3 comma 4. Step 5, check both in the other original equation. My other original equation was 4x minus 3y equals negative 24. Since I've used the bottom one to find my second variable, I have to check them in the top equation. I plug in negative 3 for x and 4 for y, and I get a true statement. So there's the answer, negative 3 comma 4, because it checked. Let's try these systems. So let's go through the steps, right? That one's already solved. I plug the short name in for the long name. Uh-oh. I couldn't solve for x because x disappeared. Make sure I did it right. Y equals 2x plus 9. I put the 2x plus 9 in for the y in the top equation. 4x minus 2 times 2x plus 9 equals negative 24. Negative 2 times 2x is negative 4x. Negative 2 times 9 is negative 18. 4x minus 4x goes away. So I end up with negative 18 equals negative 4. Well, that can't happen. So if the variable disappears and you get a false statement, because obviously negative 24 does not equal negative 18, that means there's no solution. Because no matter what we choose for x, we'll never make it true. There's no solution. Okay? Look at this example. 2x minus 2y equals 14, and x equals y plus 7. Well, again, it's already been solved for x equals, so I put the y plus 7 in for the x. What? Okay, let's make sure I put y plus 7 in for the x, so 2 times y plus 7 minus 2y equals 14. Distribute 2y plus 14, the two y's cancel, and I get a true statement. So again, the variable disappeared, but this time I got a true statement. And that's the difference between these two. In both of these cases, the variable disappeared. When I got a false statement, which meant no solution, here I got a true statement. The variable disappeared, and I got a true statement. Therefore, there's an infinite number of solutions. In other words, they're the same line. For the previous one where there was no solution, the lines were parallel. Here, they're the same line. So I write the answer as the set of xy, all xy such that. That's what the red is. The curly braces mean the set of xy. The vertical line is such that. And then I list one of the two equations from the system. That's the criteria. Just one of the two equations. It doesn't matter which one. I hope the presentation was helpful. thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.